So we're going to spend just a little bit of time going through and finding some square roots when there are variables. So this first one right here, it says x squared. So I think the best way to start doing this is to know that that means the square root of x times x. Well, a square root, we could put a little 2 there, and that really just means that we're finding sets of 2. So what is the square root of x squared? Well, there's one set of x that pulls out, so my solution is x to the first power. And then look, everything has come out of that radical symbol, so my solution is just x. Let's go to this one. It says 9, so the square root of 9 times k to the 10th. So I'm going to pull that apart. And so I'm going to have the 9 here and the k to the 10th here. So a couple different ways to think about it. Let's just start right here. What is the square root of 9? Yeah, that's 3. Okay, now this over here, k to the 10th, and it's the square root. So that means I'm looking for pairs. Well, how many pairs of k are there if you have k to the 10th? If you need to write it out, have at it. So I'm going to make the square root k 2, 3, 4, 5, 6, 7, 8, 9, 10. That didn't work real well. I kind of ran out of space, but the point still stands. So here's a pair of k's that pulls out. Another pair of k's that pulls out. Another pair. Another pair. And another pair. So how many pairs pulled out? Yeah, 5. So k to the 5th. Is anything left under the square root? Nope. So there's my solution. So what about this one? N to the 5th. I could, if I needed to, write that as n times n times n times n times n. So I see that I can pull out 1 pair, 2 pairs, and I have 1 left over. Well, that's fine. So n squared is what pulled out, and I still have 1 left over. So it didn't have a pair, so it has to stay in there. Now, you see up here, it says something, if m, so whatever that is right here, is a multiple of 2, you just end up with whatever you can pull out a, and you just cut that m, whatever it is, you just cut it in half. But here, look at this. It's not a multiple of 2, so you figure out how many pairs can I get. So you just take out, so you know that there's going to be 1 extra, and then 1 less than this. So this, I have n to the 4th. I could break it into the square root of n to the 4th times square root of n. Well, this right here gives me n squared. And then I just have 1 n left. So if that is helpful to you, do it that way. Or if you just need to write it out and circle it until it gets better, please do that. So let's try a couple more. Let's go to this one, 6. So p to the 15th. So I'm going to think about that, p to the 15th. So 2, 4, 6, 8, 10, 12, 14, but that's as far as I can go. So that means I have how many pairs? 7 pairs. And there's 1 left over. We'll come back to that. Then I look at the q's. How many pairs are in 9? So I'm counting on my fingers, 2, 4, 6, 8. So 4 pairs. And then the r's, can anything happen there? Nope. So what's left? Inside my square root, I have 1 p left, 1 q left, and 1 r. You won't ever have more than 1 of anything inside a square root because it's looking for pairs. Now let's look at this one. So we'll do 1 more because, actually maybe 2 more. This has 2 things going on. You've got the square root of 63 and the square root of b squared. So you might notice that b squared, well, that just pulls out as 1 pair. 63. Well, square root of 63 breaks down into 9 times 7. So square root of 9, square root of 7. Square root of 9 is 3, but the square root of 7, that's not perfect, so I leave it out. Okay, now let's try number 9, because that's a big number. And do you notice that there's this 8 on the outside? So I'm just going to write that down so I don't forget it. And I'm going to multiply it by stuff because that 8 is multiplying there. Okay, let's, we can deal with different things. I see this y to the 4th. I see that that's going to pull out as nice pairs. So if you want to, you can write it down, but you're going to need to leave some space. Do you see there's no pairs of x's? So now I'm going to deal with the 320. What goes into 320? 2 times 160. Ooh, I see 16 goes in there. But let's, okay. So let's do this. Let's, that doesn't really help us. So let's say 4 and 80. If I do 4 and 80, that's totally cool. I know that the square root of 4 is 2. But I still have the square root of 80, and I think that that can break down into something. And so you might be like, well, 8 and 10. Yeah, but 8 and 10 doesn't really help you. So how about 4 and 20? Just so you know I'm going the slow way. You could totally do this faster. But this works for me. So square root of 4 is another 2. So I pull that out, but I still have square root of 20. You can break down the square root of 20 again. What does that break into? 4 and 5. So we can pull out another 2. Awesome. Then what's left inside there? Well, this 5 and a random x from the beginning. So now I have to come back and say all of these things. I have to multiply them up. So 8 times 2, 16, 32, 64. 64y squared all over, or times square root of 5x. Now, just in case, so 320 is a really big number. You see how I just kept pulling it down here? You can do that. Or you could also do this. Remember way back to 6th grade, and sometimes you would do a factor tree. If I did a factor tree on this, maybe you'd see, I think we did 4 and 80. Great. Oops. Now, I could pull this down and look at, do you see another 4 comes out of 80? And it's 4 times 20. Is that right? Yeah, 16. Okay. So watch this. Remember over here, like when we had the y's, we pulled out a pair of y's? Well, you could also pull out a pair of 4's. And then here, this gives you 4 and 5. And you could break it down into 2 and 2 and pull out a pair of 2's. That might have been faster. And so then you would have had 8 from over here times 4 times 2. Would that get you to the same place? Would that still get you to 64? The answer is yes. It just might be a little bit faster method of getting there. Or maybe you're like, hey, 64. No, not 64. 8. Yeah, 8 times 8. 64 goes into 320. 5 times. I would not have seen that. But you might be able to pull out bigger things, and that's okay. So the numbers usually we just take and we factor it down, but you can also, if you see it, you can know that there's pairs to pull out too. And then we always just pull out pairs of our letters. There you go.